Okay, for 7.2, if I saw this on number 1, we got the equation of a circle centered at 8,3 with radius 19. Quick take on that, I would say, well, if my center is at 8,3, that means new 0 for x is 8, so we'd be like x minus 8. And then the y part, the new 0 for the y part, is 3, so y minus 3. And then it's the old Pythagorean theorem thing, so x squared plus y squared equals radius squared. All I would be doing is x take away 8 squared plus y minus 3 squared equals 19 squared. And that's all you'd have to write. It might benefit you to do 19 times 19 and figure out what that answer is, but whatever. That's all I would do for something like that. Okay, second one now. If we had an equation here and we got to figure out, this doesn't look like the circle equation that we just had. This is weird. But we got to figure out, like, what is the center and what is the radius given this information. Maybe we'll just make this equation look like what the other one did look like. And so that's more of a complete the square type issue. If I were to take this, it seems like I got x's here, x squared, and regular x's here. We'll put the x's together first. So we got x squared, and then a minus 10x. And then we got the y terms. There's a y squared plus a y squared, and a plus 10y. It's a y. And then, what else is there? Plus 1 equals 0. And then a little bit of completing the square will get us to where we need to go. And so if I just look at the x's, remember how that goes? Well, actually, before we look at the x's, this extra plus 1 is probably not needed. So we're going to minus that to the other side. So minus 1, equals negative 1 on the right-hand side. But then to deal with the x's and the y's separately, we'll start out with the x's. We have x squared minus 10x plus some mystery number we're going to add in there, complete the square style, plus then y squared plus 10y plus some mystery number there in order to force these things to factor well. And so if I were to look at this, just the x part, don't worry about the y's at all yet, but x squared factors into x's, and then I'm wondering what goes in to some mystery number that adds up to 10. They times to the mystery number, third number, add up to 10. But if I want this to look like the last equation, I want both of these factors to end up being the same. So that, I guess, what the long haul end of this is, the goal is I want these to be the same so that I could end up saying x plus whatever squared. Because it'll be two of the same thing here. And so if that's the case, let's see what we can do here. I'm wondering, okay, so probably the best approach would be I need to fill in the blanks here in these factors of saying, like, what goes into, well, I don't know what goes into mystery number, so that ain't going to work, but I need them to be two of the same number. I need the two yellow spots to be two of the same number, but I also want to make sure that they add up to 10. If that's the case, if I want them to be the same number and they add up to 10, I think 5 is the only way to go. Two of the same number that adds up to 10 has to be 5. It's just half of 10. And if those are 5s, then that makes mystery number 25. So that'll be 25. But just don't forget, if you add a 25 to this side of the equation, you'll have to add a 25 to the other side. And then we'll do the same thing with the y's. And weirdly enough, in this case, this is a 10 as well. So this will go quickly. It's just a plus 10. So we're wondering, okay, what can I add? Let's see here. Yeah, two of the same number. I want two of the same number that adds up to 10. So it'll be plus 5 and plus 5 this time. And if that's the case, then those end up timesing to 25 as well. So 25, and then add 25 to the other side. Now we have ourselves an equation of the circle where we can say, well, the x part is x minus 5 twice, so that's x minus 5 squared. The y part is y plus 5 twice, so that's y plus 5 squared. Equals whatever the heck is going on. This was 25 and 25 and minus 1. That's a 49 by the time you add it all up. And then remember, if I were to answer, like, what is the center, that's where this h and k mess comes in. We're just looking for what makes new 0 here. So new 0 for x part is a positive 5. And so the new 0 for the y part is negative 5. So our new center here, we'll put it in blue. The center of this thing is actually 5 on the x part and negative 5 on the y part. A little opposite of what it looks like. And then the radius is found in the 49, because now we're saying x squared plus y squared equals radius squared, so the radius must be 7, because 7 squared makes 49, or it's the square root of that number, you know? And that's all we would say. Is over here for h and k, you'd give you like the h, that's the x part of the answer, and that's 5. The k is the y part of the center, and that's -5, and the radius is 7. Looking good. What else? Okay. We got to write the standard form of a circle. You know what? I found that my thumb was right next to the speaker input thing again, the microphone part. And I'm hoping that I didn't make tons of noise for you guys. Well, time will tell. So, okay, find the standard form of the circle of the equation, you know, this thing. But all they give you is a diameter that has endpoints there and there at 0, 2, and at 7, 6. What I would do is just draw it. And so if I put this on a graph, we have 0, -2, 0, down 2. And then 7, 6, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6. Just pretend like it's up there. And then now we have what we've drawn here is these are endpoints of a diameter. Endpoints of a diameter. There we go. Meaning like there's a circle that sort of wraps around this thing, and it hits those things, those dots at both ends of the circle. And I could draw a line through it. That's the diameter that goes right through it, and then the center would be somewhere in between them. Now I got to figure out how that goes. And so if I were to draw an equation of this circle, what I need to know is where is the center and how big is the radius. And so maybe we'll take that in pieces. Let's figure out where the center is first. And if we were to do that, it seems like the center, it's the midpoint between those 2 points they gave us. So if I had this, I would take it in terms of let's find the x part and let's find the y part, and then we'll just call it whatever we get, you know. So the x part, remember, that'll be halfway between the x value of both of those points. And so, let's try something else. Okay. What was our coordinates? Oh yeah. So if we were to do looking at these coordinates here, the x value of the first one is 0, and the x value of the second one is 7, and we'll just average them. And so that's plus 0 plus 7 divided by 2. That'll be the midpoint of the x part. Well, the x part of the midpoint. And so 0 plus 7 is 7 divided by 2. So this is just 7 over 2, or 3.5 or something. And then for the y part, it'll be the same thing. We're just going to look at the y coordinate. The y coordinate of the first dot is -2, and the y coordinate of the second dot is 6. So we'll do -2 plus 6, half that, and it'll average the two of them. That ends up being 4 over 2, which equals 2. And now we got ourselves a midpoint. Midpoint is 7/2, also known as 3.5 if you like. And then the y part is 2. So that's the coordinates of this dot in the middle here, if you're ever wondering, you know. So that's 3.5 over and then 2 steps up. That looks about right for where I drew it, actually. 3.5 steps over and 2 steps up. Okay, that's the center part. Also now, we're going to need to know the radius. And so for the radius, that'll take a little bit more intense work, but not too bad. Radius, recall what they gave us is a diameter, which is the distance all the way across. We want to know how big is a radius, so that'll be just half as big as the diameter if we can figure out how big the diameter was. So if we take the 2 dots they gave us, maybe we'll just go kind of Pythagorean distance formula on it and see how far apart they are. So if I were to do that, maybe we'll figure out how far over and how high up, and then by a squared, b squared, c squared, we can figure out how far across the one dot is from the other. So let's see, if we were to look at coordinates as far as how far over goes, the first dot is at 0 steps over on the x-axis at 0, and the second dot is 7 steps over. If you look at the x values, it's a 0 and a 7. So from 0 to 7 on the x values, that's going to be 7 steps. But if we're looking at the y values, one of these dots is 2 steps down, -2, and the other one is 6 steps up. And we're wondering how far apart are those. And so from -2 or 2 steps down, and then 6 steps up, that's actually 8 steps apart. And so that's 8 steps up. And let me do that, 8 steps up. And then for the diameter, the whatever we call the hypotenuse of the diameter of this thing, that'll be Pythagorean theorem. And we're like, if I were to call that d for diameter, we would say diameter squared. Here, let's put it back in pencil. Diameter squared equals 7 squared plus 8 squared. That's 49 plus 64. Let's see here, 40 and 60 is 100. And then, what was it? 9 and 4 is 13. I'm getting 113 in my head here. So then the diameter squared is 113. The diameter then would be the square root of 113. I'm having trouble thinking of factors that go into that. So then what we'll say is that we'll just call this square root of 113. I don't think of a way to like pair that out or anything. But then we want to know what the radius is. But remember, radius is just half as big as the diameter. So we'll just say, well, so, comma, the radius is just take that square root of 113, divide it by 2, call it a day. So we got ourselves a center at 3.5, comma 2, and a radius of half of the square root of 113. And you can estimate that, the square root of 113 is 10 point something, maybe 10.5-ish. And then half of that, divided by 2 is whatever. Anyway, okay. Okay, write the equation of the circle centered at this thing passing through this thing. This is going to be weird, but similar. So this time they gave us a centered point. They give us the center point is at -8, 3, 4, 5, 6, 7, 8, up 4, 4, and there's the dot. And then they say, so that's the center dot, and then it also passes through a different dot, -5, comma 11. So 1, 2, 3, 4, 5, comma 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm way at the top of the board here. And so, let's see here. If that's the center, and this is another one that we hit, I guess we could draw the rough draft of the picture sort of like that. And we'd be like, well, I got the center at -8, 4, and then -5, 11 is the rest of the picture, or the other dot that's on the circle. Not drawn to scale. And then, let's see, we need to write an equation, so we'll need to know the center and the radius here. We already know the center, so most of this answer we already know. If we know the center, then we already know that it'll end up being x minus -8, or x plus 8, you could just do. X plus 8 squared plus y minus 4 squared equals some radius squared. We just don't know how big the radius is. So we'll do a little distance formula on that too, like we did in the last problem, and we'll figure out how big is that radius. That's all we got to do. So it's getting a little messy and taking up some space, so I'm going to put that back later. But that's all we need to do is just figure out some Pythagorean distance here. How far over, how far up, straight up, and then we'll be able to figure out the Pythagorean diagonal distance. Okay, knowing this from the coordinates we have, the coordinates that we have are -8, comma 4. That's an x and a y. And the other one is -5, comma 11. That's an x and a y. And so if that's the case, let's see. Looking at just the x's from -8 over to -5, -8 to -5 is only 3 steps. So we'll put a 3. Here I'll put a 3 in some other color. 3. And then looking at the y parts, we're going from +4 to +11. Or this one is up 4 steps, and then it goes up to 11 steps. So from 4 to 11 is 7 steps up. So then the up value is 7. Then we're just doing a squared, b squared, c squared once again to get the radius. And so here we go. We'll say, oh, I keep on touching the iPad. And I'm hoping that I'm not ruining the recording. Time will tell. So we got radius squared equals 3 squared plus 7 squared. And then we're working from there. So let's see here. 3 squared is 9, and 49, so that's going to be like 58. So we have radius squared equals 58. And the radius then will be the square root of 58. Looking good. So we know whatever that is, 7 point something is square root of 58 though. That's not going to work in blue like that. That's a radical 58 for the radius, and that's all we needed. Because now we can say, oh, okay, I can write the equation of the circle then by just going like we already know how to do, using the center point. That's x take away negative 8, or x plus 8 squared, plus y minus of 4 squared equals the radical of 58 squared. But radical 58 squared, you might notice that the square root and the square undo each other if you have a funny radical in your radius. So it's okay just to be like, maybe I'll just put 58 then, because the square and the square root undo each other. Anyway, that's all we would have for that one. Let's see here. This is another complete the square type one like we had before. I just noticed that it had some extra numbers on it, but since it's a circle, it actually ends up going pretty smoothly to get rid of any extra numbers. You may notice that as we look at this equation, everything is divisible by 3, and so that doesn't have to be the case. But it's beneficial for us. What I would normally do is, even if these weren't all divisible by 3, I would notice that since it's a circle equation, the number next to the x squared and the y squared are going to match. And so I'll just divide by whatever it takes to get those down to a regular x squared, Fortunately, we're getting used to these, and so the numbers will be nice enough that it'll divide well. Somebody else might tell you to go about this a different way, but I'm going to suggest that we just divide everything by 3. So maybe we'll do that actually. We'll just divide everything by 3 on both sides. 0 divided by 3 is not going to do anything. And so the equation resulting will be just a 1x squared, or a regular x squared, plus y squared minus, what's 18 divided by 3? Is 6, right? Yeah. Was that an x? Minus 6x minus 5. No, okay. 30 divided by 3. Yeah, 10y plus, and then 33 equals 0. And then we can just rinse and repeat like we did on the other problem where we had to complete the square. I'll give you a quick take on it. The 33's got to go. I'll get the x's together. It's x squared minus 6x plus some mystery number. And then plus y squared minus 10y plus some mystery number equals, at this point, a negative 33, because we're minusing the 33 to the other side of the equal sign. Then we're making the factors happen, making sure that, remember, there got to be 2 of the same thing, so that in the end we can say something squared. So I need 2 of the same thing that adds up to this minus 6 here. And so 2 of the same thing that adds up to a minus 6 will be a minus 3. And if those are minus 3, then 3 times 3 ends up being a positive 9. And then I'll just, don't forget to add that to the other side of the equal sign. Same thing here, so that's x minus 3 squared. Plus, and then let's look for some factors on this one. And this is a 10 again, like we'd ran into before. And so what goes into, what's 2 of the same number adds up to 10. We're looking at minus 5 both times to add up to a negative 10. 5 times 5 is 25. Negatives will cancel, and then we'll have 25. Add that to both sides. In shorthand, that means y minus 5 squared. And so we have x minus 3 squared plus y minus 5 squared equals, and then whatever, negative 33 plus 9 plus 25, all add up to, I think that's 1. Because 9 and 25 is 34 minus 33, so I think that's 1. Looking good. So now we got ourselves an equation of the circle, and then we can tell them anything they want to know. The center of the circle is at h and k, that would be at 3 and 5. And the radius is just 1, because 1 squared is 1. So we have a radius of 1. Ta-da! H and K. Cool. Last thing. I don't know if you guys can see that it says there's supposed to be 7 slides. I don't know. I see that. But really, the last one's blank by accident. I don't know. I didn't know how to get rid of it. Whatever. So we got to find the center and the radius of a circle. It's got a diameter that has endpoints here and there. I feel like maybe we've done this already. Did we do this already? Let's see here. They gave us endpoints of it. What the heck? Okay. Not that one. Whoa. Yikes. I'm not dreaming, dude. I'm out of my mind. I think it's just because I was practicing this one earlier, because I wanted to make sure I knew what I was doing. Good thing it now looks like I don't know what I'm doing. And so from here we have the center and the radius of the circle with a diameter that has endpoints, this and that. So this is 2 endpoints of a diameter they're giving us. If we were to draw this, it would look like -7. Here, you know what? I'll make use of that cool blank slide. If we were to draw this, it would be at -7, comma, -8. And then what was the other one? 9, 0? Yeah. And then 9, 0. These are endpoints of a diameter. So the way this picture could look in the end, let's make that look better. The way this picture could look is -1, 2, 3, 4, 5, 6, 7. -8, 2, 3, 4, 5, 6, 7, 8. We're down there. And the other dot is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. We're there. Man, I feel like I had done this already with you guys. Freaky. And now all we got to figure out is the equation of the circle, I think, to be able to tell them anything else they want to know about it. But that means we got to know where is the center point here. Man, this feels so much like one of the other problems. Oh well, I'll stop harping on it. Probably, I feel like there was another problem and I just didn't see it when I looked back. Anyway, here we are. We got this, whatever. It's a circle. We got to figure out the center here and how big is the radius. And so here we go. If I were to do this quick take, center is once again is the midpoint between the two. I know we did this. Who cares? And so midpoint between the two, we'll just look at the x's here and average them out. That's for the x part of the midpoint. That'll be -7 plus 9 over 2. What is that? 2 over 2. So I think that's 1. And for the y part is, let's see here, the y and the y. So that's -8 plus nothing over 2. So that's going to be -4. So we got ourselves a midpoint at 1 and -4. So that'll be the center of our circle here. Center of the circle, what was it again? 1, -4. We got to know the radius now. Radius, once again, we can figure out the radius directly, or we could just take the dots they gave us and figure out the distance of that, and then take half of it. However you want to do that. Since we've done it this way before, I'll go and do this again. So we have diameter is given from one point to the next. We got to figure out, oh yeah, we don't know what the diameter is, so we got to figure that distance. We just know where they are. So we'll see how far over and how high straight up. And then we'll figure out the diagonal distance of the diameter. So let's see if we can figure this out analytically. The x part for the left and right part of this, that's x values. So we'll look at the x values of it. I have an x value of -7 all the way over to +9. So from -7 all the way to +9, that's a lot of steps in between. -7, +9. If I add that all up, that should be like 16 steps, I think. So we'll say 16 steps that way. And then on the y part, let's see here, that's from -8 up to 0. That one's not as tough. That's only 8 steps going from -8, I guess, down to, or up to 0. So that'll be 8 steps up. We'll put it in blue. And then it's back to a squared, b squared, c squared. Let's see if I can add an extra slide now that I've drawn all over everything. No, we'll just erase stuff, I guess. And then, oh, let's not erase that part. Okay. That's the diameter, right? So we'll say diameter then squared. Diameter squared equals 16 squared plus 8 squared. And we'll just run those numbers, you know? And so d squared equals, oh, I don't know what that is, 256 plus 64. I'm thinking it's 320. Let me know if I'm wrong about that number, but I think it's 320, and then we'll square root it to get that diameter. Diameter equals the square root of 320. Let's see what we can pair out of that one. That's 32 times 10. So there's a lot of things that go into that. If we go to 32 times 10, 10 just becomes a 2 times 5. 32 ends up being a bunch of 2's. 2 times 2 times 2 times 2 times 2 by the time you do it. Circle in the 2's. That's 5 2's there, plus another 2 from the 10. And then a 5, so that's 6 2's and a 5. So if I were to to simplify this down, essentially it would look like this, guys. We'd say the square root of 320 broken down into prime factored form as 2 times 2 times 2 times 2 times 2 times 2 times 5. And then taking out pairs, pair of 2's becomes a 2 outside, pair of 2's becomes a 2 outside, pair of 2's becomes a 2 outside. Now all of those are out. The only thing that's left is a 5 inside. So now we have a 2 times 2 times 2 outside, radical 5, also known as 8 square root 5. And then remember, that's the diameter. So now if we have 8 square root 5, let me clean that up a little bit.